Inspection and maintenance tasks at height, such as tree inspection, are dangerous for humans. However, by enabling UAVs to perform these tasks, we can minimize the risks involved. We present a multi-rotor for interaction with vertical, cylindrical target objects with rough surfaces, such as trees. The UAV has a pair of tilting rotors to produce an independent forward thrust, and a landing gear that can reconfigure into a gripper, which can stabilize the UAV against the target. This reconfigurable landing gear has 5 degrees of freedom, 2 per finger and 1 for the reconfiguration. Our design is unique because these joints are all driven by a single actuator housed near the UAV's center. Rubber bands at every joint passively draw the system into the landing gear configuration shown here. From here, the actuator drives each joint via a series of cables and a pulley differential. To drive the various joints in a defined sequence instead of all at once, we implemented unique part geometries for the mount, the base link, and the finger's proximal and distal links to lock certain joints in specific configurations without requiring more actuators. In the landing gear position, the rubber bands and the weight of the UAV draw a disc on the proximal link of each finger into a recess in the mount. This ensures that the landing gear doesn't collapse out from underneath the UAV during landing. As the cable is wound up, these locks are released and the landing gear rises. The shape of the contact points between the proximal links and the mount prevents the proximal links from rotating. This ensures that the landing gear can reconfigure into the gripper without initiating a grasp. Once configured as a gripper, contact between the base link and the mount prevents further rotation of the reconfiguration joint. At this point, the proximal links are no longer blocked by the mount, and the fingers start rotating, initiating a grasp. As the fingers rotate, the discs on the proximal links pass through slots on the mount, ensuring that the gripper extends rigidly from the front of the UAV without collapsing downward. Finally, unwinding the cable runs the system through the same configurations in reverse order. In this clip, we show the reconfiguration sequence during the UAV's approach towards a 3D printed target object designed to resemble a tree. First, we see the transition from the landing gear position to the open gripper position. Now the system acts as an under-actuated gripper that can comply with the shape and size of the target object during grasping. We observed 3 cases: free flight, grasping, and grasping while pushing with the tilt rotors. We see that the gripper reduces the UAV's deviation from its initial position and yaw even with the tilt rotors pushing forward. This was consistent across multiple tests. Overall, compared to free flight, we observed an 80% reduction in maximum and mean deviation when grasping and pushing. This is a promising step towards safe, high-precision interaction with target objects like trees.